Let's take a look at what's going on here. We're joining the customer table to the order table based on a match between customer ID in the customer table and customer ID in the order table. So far, so good. But what if we have customers that haven't placed any orders yet? In that case, there won't be a match to be found, and those customers simply would not show up in this query. But if we want to see all the customers, every customer from the customer table, or even every customer that meets certain criteria in the customer table, and then any orders that exist for that customer, we can do it by using what's called a left join. There's left and there's right. And it really just has to do with which table is to the left of the word join and which table is to the right of the word join. If you want to see all the values from the table on the left, then you just use left join. And that's what we're doing here. So I'll select this statement, I'll run it here in Query Analyzer, and we're looking at the first order for all of our customers. But if I scroll down, you'll notice that we're also seeing that Gene Carson and John Carson had no first order. They have a null value over here on this side of the join. There was no matching values over here, and yet they still show up in the return set of our query. That's the usefulness of creating a left outer join. I'll just tell you another example where this might come up. Suppose we were doing a lookup. Suppose we were looking up information on our instructors and we wanted to see which department they were in. But some instructors hadn't been assigned to a department. If we want to see all the instructors, then we would use an outer join and bring in only that lookup value from the department table for those where there is a match. This is very useful when you have a foreign key that can sometimes contain a null value. A left outer join will allow you to see all the records in one or the other of the tables. Here's another example. In this example, we're going to make use of the fact that we get a null back if there is no match on the other side, and we're going to create a query specifically designed to find any unmatched values. In other words, we want to find out who are the customers that haven't placed orders yet. So we're going to select the first name and last name grouped together as customer name for each of our customers. We're going to select that from TBL customer left join TBL order. In other words, show me everyone from TBL customer. But not everyone. Only those where TBL order.order ID is null. And because order ID is the primary key in TBL order, we will not have a null value unless the order information is completely missing. In other words, this query allows us to find all the customers who haven't yet placed any orders. And in this case, we have two of them, the two that we saw in the last example. Now, sometimes you may want to go in the other direction. Suppose we suspect that we might have some order records with a customer ID in them that doesn't have a match in the customer table. This will never happen if we've enforced referential integrity all along while the data was being entered, but perhaps we're importing data from another database where the designer was not so careful with their data. And we want to check here and find out, do we have any orders with a customer ID that doesn't have a matching value in our customer table? By using right join here, we're able to say, give us everything from the order table, match it up with the customer table, and show us, in this case, the first name and last name and so on, and the minimum order amount from these joined tables. But even if I don't have a match in the customer table, I want to see whatever information I can get back from the order table. Now, it so happens in this example, if I run it, it's going to be giving me the same information back as if I had used an inner join because we have matches across this join because we've used referential integrity. But again, you can go in either direction, getting all the records from one table or the other. What if you want to get all the records from both sides of the join? This is called a full join or a full outer join. We want to see all the customers, whether or not they have an order. We want to see all the orders, whether or not there's a matching customer. And if there's a match, we want to see the corresponding information for customers and orders. So this is what's called a full outer join, and this is something that SQL Server supports, and not all databases support full outer joins. Now here's an example where we are selecting the first name and last name as customer name. We're selecting a sum as the total sold. And we're selecting this from TBL customer left join TBL order. In other words, we're going to see information for all the customers and any information that may be available on the orders. Also, we're doing an inner join from that order table to the order detail table. You might think that this would work because, after all, if we're getting back information from the order table, why not be able to also pull in information from the order detail table? But there's a problem with this. If I run this, the information that comes back to me is not going to be accurate because in some cases we're going to have a lack of a match in the first join, and for that reason it will not give me correct results in the second join. So the bottom line is, anytime you want to combine an inner and an outer join, be sure that you either perform the inner join first and then the outer join, as we've done here. So we're joining together here as an inner join, orders and order details, and then doing our outer join to customers, making it a right outer join to pick up all the values in TBL customers. This will give us back the proper results. Another possibility is that you could do only two outer joins. In other words, I could have said TBL customer left join TBL order, and then over here left join TBL order detail. That also would give me valid results. Even though we know in this case that there's a match between all the orders and order details, left join will make it unambiguous what we're expecting to get back. So, two choices to avoid ambiguity when you combine inner and outer joins. Either make all the joins outer joins pointing in one direction, or do your inner joins first and then your outer joins. Back in that view builder that we have, I'll create a new view. I'll go ahead and add in the customer table, TBL customer, and the order table, TBL order. This gives me an inner join based on customer ID. That's the default. I could select this and remove it and add another join, but this is the default it gives me based on the referential integrity relationship that we've created. Now, suppose I right-click on that join line. It's a little bit hidden, but this allows me to turn this inner join into an outer join. I can select all rows from TBL customer, and notice it now changes the symbol, so instead of being a diamond, it looks more like an arrowhead pointing in this direction. And that's a convention. Very often you'll see an arrow pointing away from the table that you're going to see all the values from and toward the table that you're going to see matching values from. And if I hover over this, you see that it tells me that I've created an outer join. So you can use this view builder for building outer as well as inner joins.